Hello everyone, welcome to the Scumdogs Kennel. I'm your host, Chris Williams, and in today's Cryptid Corner mini-episode, today I have a couple of articles dealing with life in outer space and the various forms it might take. The first article we'll be reading about is, one involving the government asking various researchers about what forms alien life will be found in space, at least what they theorize. So let's read that first article. NASA commissions microbiologists to find out what aliens look like. Let's get into it now. While movies often show aliens as little green men, real extraterrestrial life, if it exists in our solar system, will likely be microscopic. NASA recently gave microbiologist James Holden $621,000 to study what life on Jupiter's moon, Europa, might look like. His research takes an unexpected approach, studying volcanoes deep in Earth's oceans. Europa's icy surface hides a vast, salty ocean, possibly warmed by a molten core. We think, based on our own planet, that Europa may have conditions that can support life, says Holden, pointing to Earth's hydrothermal vents as a model. NASA's Europa Clipper mission, launching soon, will test how habitable the moon really is. Holden has studied deep-sea vents since 1988. I've been looking at deep-sea volcanoes since 1988, he says, to get our microbes from them. We use submarines, sometimes human-occupied, sometimes robotic, to dive a mile below the surface and bring the samples ashore. His lab recreates the extreme conditions these microbes thrive in. No lights, no oxygen, just chemicals from the vents. Since Europa's ocean might be similar, Holden believes any life there could resemble these deep-sea organisms. We have long had a basic interest in knowing if there is life beyond our planet and how that life would function, Holden adds. Now everyone, the article doesn't mention by name, but the notion of extremophiles is what they're talking about. They think that life might exist on Europa with the deep volcanic vents there due to having life similar to that here on Earth that's basically found in the deep ocean around, our own volcanic vents and other volcanic areas that they found microbial life surviving. So the idea of looking at these places and finding life is a real possibility, folks. Now, my one problem with this article is that it thinks that this life would basically be something we'd expect, which is both true and also false. It could very well be something we've seen before, folks, just in a new form, but I wouldn't say that covers every possibility. But let's continue with this article and we can talk about it a little more. It's exciting to think that the answer to the secret might be here on our planet, but Europa isn't identical to Earth, so its microbes, if they exist, might work differently. Holden's research focuses on how alien microbes could generate energy. Earth's hydrothermal microbes use enzymes called hydrogenases to break down hydrogen, but different types of hydrogenases could produce very different life forms. Indeed, folks, there's that possibility. So that by studying this possibility, we could maybe theorize what these entities might look like. Either way, let's continue. Iron, sulfur, and carbon from vents also interact with hydrogen in ways scientists don't fully understand. Our research will be to determine how the different chemical processes contribute to an organism's physiology, says Holden. If Europa has life, it may not look exactly like Earth's, but studying our planet's extremes gives scientists their best clues. As Holden puts it, the key to finding aliens might be hidden in the darkest depths of our own oceans. And I have to agree to some extent, folks. That could be the truth. Because indeed, life could basically exist down there, and it might give us an idea what life might exist out in space. The way it could basically, behave, the way it might look, and maybe even interact with the world it basically inhabits. But know this, folks, there will probably be vast differences as well. Because I can tell you this much, folks, that any life out there, may be similar, but there will probably be marked differences. Maybe they'll be more adapted to extreme gravity, or maybe there'll be other things. But there's also a possibility that maybe life will basically, be very similar to what we have here on Earth as well. As unlikely as it is, folks, because I do have a few theories about that too. But let's move on to the next article, because it's also another very interesting one. Earth's deep microbes hint at life on sunless alien worlds, and talk about how other extremophiles, other life forms, could exist in places that we don't expect. So, let's read on. The discovery not only changes our understanding of underground ecosystems on Earth, but also hints that similar life could exist on other planets where there is no access to sunlight. Scientists believed that sunlight was the basis for all life on Earth, But now, researchers have discovered a completely different way of life, one that doesn't require light at all. Scientists have discovered that microorganisms living deep beneath the Earth's surface can obtain energy from special chemical reactions that occur due to cracks in the rocks caused by the movement of tectonic plates. Indeed, folks. Much like basically the life forms that exist in our oceans around tectonic, fissures, where they can basically soak up the energy from the molten interior, there are other ways that maybe life can exist and thrive, underneath the Earth itself, folks. So let's wonder about that. So, if that means that life could exist down there, what could possibly exist in our own universe outside of this planet? Maybe in the depths of space where there is sunlight, but nothing else but radiation. Some people do think that life could exist in literally the very emptiness of space. They're called atmospheric beasts, and is a theory I've talked about before, folks. And we'll go on about that after we read through the rest of the article. This process of cracking the Earth's crust creates faults that allow water and gases to circulate, enabling chemical reactions that don't require sunlight. This discovery indicates that similar microorganisms may live on other planets where sunlight is not available. The study was published in the journal Science Advances. The study's authors wanted to find out how microorganisms living deep underground gain access to both energy and oxidants, two essential components needed for the chemical energy that sustains life. Previous studies had shown that microorganisms could use hydrogen as an energy source, but the origin of the necessary oxidizers remained unclear. To solve this mystery, the scientists recreated in the lab the process by which cracks form in rocks, which typically occur along underground fault lines. Very interesting, folks. But let's continue, because there's a lot more to get through. The researchers applied pressure to different types of rock to simulate the effects of crustal movement. As the rocks cracked, reactive molecules known as free radicals were released. We propose that crustal faulting can generate various redox pairs and drive phi redox cycling, thereby providing a sustained energy source for subsurface life on Earth and potentially on other planetary bodies, the authors note. These radicals then reacted with water to form hydrogen and hydrogen peroxide, an oxidizing agent. Together, these substances form an energy-rich chemical environment, but the scientists discovered something even more important. It turns out that cracks in rocks produce 100,000 times more hydrogen than other known processes, such as the reaction of water with certain minerals or fission by natural radiation. The experiment showed that hydrogen and oxidizers change the form of iron in the surrounding water and rock, triggering a cycle of iron from an oxidized to a reduced state. This redox cycle also supports reactions involving other elements important for life, such as carbon and nitrogen. Scientists believe that earthquakes or even minor tremors can create chemical conditions that microorganisms use to survive without the need for sunlight. To survive in the deepest parts of the Earth, microorganisms use energy obtained from oxidation-reduction reactions, scientists say. The discovery changes our understanding of where life can exist. The study shows that geological activity, even without sunlight, can provide enough energy for ecosystems to survive underground. If such chemical reactions can support life on Earth, similar conditions may exist on other rocky planets or moons of planets with active geological processes, scientists say. Indeed, folks, we kind of talked about that in the first article we read today, folks, that life might exist, on Europa. It could exist even on Mars, folks, underground. Some people think that basically due to underground water and maybe chemical reactions, with both the planet itself and maybe with volcanic, tectonic plates, that maybe life could thrive underneath the Martian surface, as well as on Europa, folks. That could very well be the truth. But remember, I mentioned earlier atmospheric beasts. Now, it's a theory that basically in the upper atmospheres or even in deep space with basically gas clouds, that maybe life could basically evolve. I mentioned this, folks, that maybe due to radiation and sunlight and maybe chemical reactions with gas clouds, that maybe it could produce a type of organism that could thrive out there. But like the organisms that exist under the ground, they'd be adapted to this type of environment. The only real, similarity between these organisms, folks, is that they're both extremophiles, that they can exist in environments that we just didn't think was possible. Either way, folks, I've mentioned this theory before in various videos and live streams before, and maybe, indeed, such forms of life could exist. But, folks, We're at the end. So please go subscribe to my YouTube channel, Read Comics That Are Bad For You. You can use the YouTube link down below in the descriptions of the chat to go subscribe to me. Hit that like button for me. Make sure you're still subscribed. Leave some comments down below. Hit that bell for notifications. Hit the part of the bell that will give you all future notifications, and please share this video out. I'm Chris Williams from the Scumdogs Kennel. Thank you all for joining me. I'll be back again tomorrow with another great video, so be sure to come back again then. Till next time, folks, I'll see you all again soon.